Okay, so today we are going to do lines of best fit, and we're going to be using the calculator a lot. So there'll be times when you might want to pause, get the stuff in on the calculator on your own, and then unpause the video and make sure that you've got what I've got. So remember, I don't ever get to see your calculator when you're doing the work. All I see is your paper. So you need to be really careful that you type in the correct numbers, double check, etc. So line of best fit is a line that is drawn that represents an approximation of the data on the scatter plot. The line doesn't have to pass through all of the points, but it has to match the trend. So if you've got a positive correlation, your line of best fit should be going up with a positive slope. If you've got a negative correlation, your line of best fit should have a negative slope going down from left to right. There is something that is called the correlation coefficient, and the correlation coefficient is always represented by this letter R. This correlation coefficient is the measure of how closely a set of data points falls along the line. Well, if you think about slopes and you think about falling along a line, you're going to have either a positive slope or a negative slope. So the range for your correlation coefficient would be from -1 to +1, with -1 being a strong positive correlation and +1 being a strong positive correlation. Basically what happens if you think about test scores, correlation coefficients are usually always going to be decimals unless they actually hit -1 or +1. And if you change all of these numbers into percents, then anytime you have a number that's in the 90s or above, you're going to have what's called an excellent correlation coefficient. If you have something in the 80s, and that's going to be the decimals, it's like getting an 80 on a test. It's going to be a good score. If you have any of the decimals in the 70s, we're going to call that to be fair. And then if you have anything that's below 70s, we're going to call that to be poor. Now, it doesn't matter what the sign of that decimal is, whether it's positive or negative. Think about absolute value. Anything in the positive or the negative 90s is excellent. Positive or negative 80s is good, and then et cetera, et cetera. There are two other words that you need to know, and one of them is interpolation, and one of them is extrapolation. Interpolation is a use of a line or its equation to approximate a value between two known values. Okay, so if it's a value between two known values, we know it's going to be an example of interpolation. If you use a line or its an equation to approximate a value outside the range of known values, it's extrapolation. And you'll see how this goes when we get to some of the questions. Your next page, you've seen most of this before, but then we give you some more things in terms of graphing lines on your calculator. 1 and 2 you should already be familiar with. 3 and 4 are the new ones. You might want to consider rearranging these two bullets under step 3 and turn your diagnostics on first before you do the others. So you might need to refer to the sheet as you're doing your work on the calculator. What we are going to do here is we are going to start entering in data into the calculator. We're going to make the scatter plot, et cetera, et cetera. So what I am going to do is I am going to show you how to enter this data in for the first one. I'll do all the steps for you so you can see what's going on. I got to get the calculator to come up, and then we'll move on from there. Actually, one thing I need to let you know is when we're talking about the table that's showing the average National Football League, the NFL, player salary in thousands of dollars from 97 to 2001, the year is your independent variable. That's what goes into your list 1. The salary goes into your list 2. Pretty much whatever they give you first is going to be your list 1. Whatever they give you second is going to be list 2. So to get everything into the calculator, to use the actual instruction sheet, what you need to do, and the first thing I'm going to do is, well, my RAM is cleared, so that's good. So you're going to go to the word stat, and you're going to hit enter for edit. In list 1, make sure there's nothing there. If it is, you're going to have to use the bullet 2 to clear out the lists. Remember, do not delete, just clear. And then you're going to enter in the data for list 1 and list 2, making sure that after you enter it in, you go back and double check that you've entered in the correct numbers. Okay. So I've got 1997 with 585, 1999 with 708, 2000 with 787, 2001 with 986. So that's great. In order to get my scatter plot, I need to turn, I'm now number 2, make a scatter plot. Turn plot 1 on, which you can go through second y equals, stat plot, etc. Or what you could do even faster than that, so we could go and turn stat plot 1 on by following that list, just clicking onto on, and everything is the same. Okay, we could do that. Or what you could also do is just go to y equals. If plot 1 is highlighted, plot 1 is on. If plot 1 was not highlighted, my plot wouldn't be on. So a shortcut would be turning your stat plot on by just going into y equals, going up to plot 1, hitting enter, and coming off of it. There should be nothing in any of the y equals equations. Once the data is in, you should be able to go to zoom 9. You can arrow down to 9 or just type 9. It doesn't really matter, but zoom 9. And now you should see the graph. So this is a positive correlation for sure. I'm going to pause it for one. Well, no, I'm not. I'm just going to keep it up here. This is a positive correlation. You're going to write that in 1 second. And now what we need to do is find the line of best fit. And to find the line of best fit, we're going to now go to step 3. Now, step 3, we said we need to kind of flip those 2 bullets. So we need to be able to turn the diagnostics on. So what it says to do for that is to turn diagnostics on, go to second 0, which is your catalog. Your catalog defaults you to A, it's alphabetical order. You could scroll down to get to the D's, or you could see right here above this X -1, there's a letter D in green. If you hit X -1, it takes you all the way down to the D's. So I'm going to go down, I'm going to find diagnostics on. I've got 2 choices, off or on. We want them on. You're going to hit enter once, and it's going to say, shall I turn diagnostics on? And you're going to confirm that by hitting enter again. And now it's done. So in order to find the linear regression, or the line of best fit, what we are going to do is follow the prompt on the next bullet, which says go to stat. Arrow over on the top to calc. Go down to choice 4, which is linreg. Now we call linear regressions y equals mx plus b. This is calling it y equals ax plus p. It doesn't matter. Ax plus b, mx plus b, same stuff. So you're going to hit enter on choice 4, and you're going to hit enter again so you get an equation. Now what pops up is y equals ax plus b, where they tell you the a is 94. They tell you the b is negative 187,163. They give you r squared, which is not something that we're concerned with, but then they give you r, which is the correlation coefficient. So what we're going to do now is write down B, C, and D. So I'm going to come back up here and I'm going to say, okay, we did the scatter plot already. We found out that we had a positive correlation because that's exactly what we saw. So we've got a positive correlation here. We found the line of best fit. That's the equation that you're looking for, but you really need to write the equation, and the equation becomes y equals 94 was the A, x minus 187,163. And then the correlation coefficient, the r, rounded to the nearest hundredth, 2 decimal places, r comes out to be 0.96. And if you got a 96 on a test, you would have to say that that was excellent. Okay, let's just make sure that I got the right stuff here. So 94x minus 187,163, 0.96. It's actually 0.95, not 0.96. So I don't know why I have that incorrect. Let me fix that. 0.95. Okay, so now I should have everything right. Alrighty. So now what we have to do is we need to use the table of values to predict an NFL player's salary in 1988. Now they're telling you this is an example of interpolation, and the reason why that's the case is because if we go back to the table, 1988, this value right here, is within 1987 to 2001. So that's interpolation. So what we now have to do is use the table of values, but when I go to my calculator and I go to my table of values second graph, I don't have anything in there. which means what I have to do is go back to my instructions and say, okay, well, now that I've done a linear regression, what I have to do now is graph this best fit line. I'm on step 4 now. So in order to go through step 4, what I have to do is go to y equals, and then it says I need to go to vars, which is right here. I'm going to go down to choice 5, which is statistics. I'm going to hit enter. I'm going to arrow across the top to equation. It's on 1 already. I'm going to hit enter. And notice how it dumped in that whole equation for you. You can do it manually if you choose. I would definitely follow the vars 5 because when you start getting lines of best fit that have a lot of decimals in them and you hand type them, it's a very good possibility you might make a mistake. So once this is in here and I hit graph now, there's that line of best fit. I'm going to go back to where we talked about the correlation coefficient. The correlation coefficient we said was excellent. It's an excellent line of best fit. It's not perfect. It does not go through every single point, but it doesn't have to. It has to match the trend. So now that we've got this, I want to go to my table of values, and I finally see X and Y's. Well, I want to predict a player's salary in 1998. Well, that's an X value because if I go back up to my top, list 1 happens to be all my X values. So these are my X values. So what I'm going to do is go back to my table of values and I'm going to say, well, I could scroll down to 1998 or I could go down to that much quicker. And the quicker way to do it is to do your table setup. So I'm going to go to second window. My table is going to start from 1998. Now I go back to my table, second graph, and I finally see an answer. In 1998, the NFL player's salary was $649. Now that's not $649, that's $649,000, right? Thousands of dollars. So that answer is $649,000. I'm going to actually do that from here, and I'm going to type in so $649,000. Okay, so there's that one. When I now go to the next one, use the table of values to predict the average salary in 2010. That's an example of extrapolation. The reason why that is because 2010 is outside this data set. You're going to discover that, or you're going to determine that the same way. I'm going to go back to the calculator, and now I'm just going to scroll down to 2010. And here it is. 2010, it's 1777. Well, what does that mean? That means in 2007, the salary is $1,777,000. Okay? So there's that whole sheet. We need to do this again for talking about this next problem, which is gallons of ice cream. So you might want to pause this. I'm going to put all the data in, and you can try it on your own. You can see if you get what I get. I'm going to keep talking, so if you want to pause, you can pause, but I'm going to keep going. Okay, so for this one, what I need to do is go back into my calculator, and I need to go back to Stat, and I need to edit. I've got to clear these lists, not delete them, just clear them. Arrow on top, hit clear, arrow off. I need to enter in this data, 1997, 1998, 1999, 2000, 2001. Arrow over to list 2, $3.02, $3.30, $3.40, 366, 384. Let me make sure. 97, 302, 98, 330. Yes, yes, yes. Okay. I need to go back to y equals. I need to clear out what's ever there. My plot still stays on. And I'm going to do a zoom 9, a brand new window. And there's my brand new graph. This is definitely a positive correlation. So I'm going to come over here and I'm going to write positive. I got that. I need to get the equation for the line of best fit. So I'm going to go back to my calculator and I'm going to go over to Stat, to Calc, down to 4, and I'm going to hit enter once and then twice. And then I've got this up here, and they want me to round my line of best fit to the nearest hundredth. So it's going to be y equals 0.2x minus 396.36. So let me get that. Whoopsie. Let's try this. So I've got y equals 0.2x minus 396.36. Okay, and then if I come down, the correlation coefficient, R equaled 0.99. Now that's an excellent line of best fit. Let me go back to show you where we had that excellent line of best fit. Right, so 0.99, not the R squared, but the R. So then we need to do some predictions, but in order to do predictions, what has to happen is we have to get this line into the table of values. So back on the calculator, I'm going to go to y equals, it's all cleared. I'm going to go to vars. I'm going to go down to statistics, hit enter, go to equation, hit enter, and it dumped it in for me. I can take a look at that line of best fit. This is 99%, so you can see how this line actually almost hits every single point. It wasn't 100, it wasn't 1, but it's 99, so that's pretty darn good. We want to predict the cost of gallons of ice cream, half a gallon in 2010. So I'm going to go back to my table of values. I think I'm in that range already. And in 2010, when I predict ice cream, remember, ice cream costs dollars and cents. You've got to go to the nearest hundredth. So this would be $5.64. So we've got this answer to be $5.64. Okay, and then it says, well, is the question above an example of interpolation or extrapolation? Well, let's see, 2010, are we in the data set or outside? And it looks like we're outside the range of values. So I'm just going to do a quick highlight, extrapolation, and then we need to explain why that is. And it's extrapolation, and that's because the year 2010, you can see my bad typing skills, the year 2010 falls outside the range of given values. Okay, so there you go. Hopefully that's enough to get you through the rest of the homework. All right, so good luck, and I'll see you later.